You think faster. Then light travel is just an engineering problem. More energy, better engines, stronger materials. You imagine a future where we simply push harder, but that picture assumes something quiet. It assumes motion is simple. It assumes speed is just speed. Take a spinning gyroscope. In your mind it's a toy, a wheel on an axle. A clever trick of balance. You tilt it, and it resists. You push it, and it moves sideways, sideways. Not because it wants to, not because of friction, but because space itself refuses to behave the way you expect. You think motion is a straight line through empty space. You think space is passive, neutral, a stage. But the gyroscope disagrees. It quietly reveals that motion is not just movement through space. Motion is entangled with orientation, with geometry, with limits. And if you misunderstand that limit, if you treat speed like something you can just keep adding to, you are already wrong. The impossibility of faster than light travel does not begin with rockets. It begins with a spinning wheel in your hand. You believe motion is simple. An object is here, then it is there. Distance divided by time, that's all. Push harder, it goes faster. Push long enough, it goes very fast. Keep pushing eventually. Why not faster than light? This is the quiet assumption underneath every science fiction engine. But that picture only works if space behaves like a flat sheet of paper. Draw a straight line, extend it. No resistance, no distortion, just more line. Now hold a spinning gyroscope in your hand, not moving across the room. Just spinning. Already, something subtle is happening. Even if it's perfectly balanced, it resists changes to its orientation. You try to tilt it. It doesn't simply comply. It doesn't even oppose you in the way a rigid stick would. It answers differently. You apply a force downward. It moves sideways. This is not friction, not delay, not weakness in your grip. It is motion responding in a direction you did not command. And this should bother you, because your intuition says force and motion line up. You push forward, it goes forward, you pull left. It goes left, but the gyroscope doesn't follow that script. It reveals something uncomfortable. Motion is not just about position changing in space. Motion has structure. Motion has orientation. Motion carries geometry with it. When the wheel spins, every tiny piece of it is already in motion. That spinning motion stores something, not energy in the simple sense, but directional stubbornness, angular momentum. And angular momentum does not behave like linear motion. It does not add the way distances add. It does not redirect the way you expect. It rotates the response. Suddenly, motion is no longer a straight arrow. It becomes relational, directional, interwoven. Now imagine increasing speed, not as pushing along a straight line, but as altering something with internal structure. What if speed itself has orientation? What if velocity is not just how fast, but also how aligned? The gyroscope is not about balance. It is a quiet warning. Motion is not what you think it is. And if your understanding of motion is wrong at small scales, in your own hands, then building an engine that outruns light may not be a matter of power. It may be a matter of misunderstanding reality itself. Suspend the gyroscope from one end. Gravity pulls down. That part is obvious. You expect it to fall, it doesn't. Instead, it begins to turn horizontally, slow, steady, circling, precession. This is the moment your intuition fails completely. Gravity pulls downward. So, why does the motion appear sideways? If motion were simple, if forces merely stacked and redirected objects in the same direction they're applied, the spinning wheel would tip and collapse. But it doesn't collapse. because the spinning wheel is not just sitting in space, it is already moving. Every point on its rim is racing in a circle. That circular motion gives the system angular momentum, a vector, pointing along the axis of spin. And here is the subtlety. When you apply a downward torque from gravity, you are not simply adding motion. You are trying to change the direction of that angular momentum vector. But vectors that represent rotations do not respond like ordinary arrows. They don't shift directly toward the applied force. They rotate around it. The change in angular momentum is perpendicular to both the existing spin and the applied torque. Perpendicular, this is not a mechanical trick. It is not an exception. It is how rotational quantities behave everywhere. Pushed down, motion turns sideways. The gyroscope refuses to obey your linear expectations because rotation is governed by geometry, not instinct. And this matters, because what you are witnessing is not resistance in the usual sense. The wheel is not fighting gravity. It is obeying deeper rules, rules about how orientations change, rules about how rotational states combine, rules that are invisible if you only think in straight lines. Now imagine trying to increase the speed of something already moving close to light speed. You imagine pushing it forward, adding velocity, stacking motion on top of motion. But what if velocity, like angular momentum, has an internal geometric structure? What if changing it does not simply mean sliding along a straight track, but rotating within a constrained space? The gyroscope is showing you something quiet but profound. Not all motion lives on a flat surface. Some motion lives on curved spaces of possibility. And in curved spaces, the shortest path is not what you think. The direction of change is not the direction of force. The composition of movement is not simple addition. The sideways drift of a spinning wheel is not a curiosity. It is a fracture in your mental model. You expected gravity to pull down. Instead, reality turned left. If such a small object can expose the geometric structure hidden inside motion, what makes you so certain that velocity itself is linear? You are comfortable adding things. 3 meters plus 2 meters equals 5. 10 kilometers per hour plus 10 more equals 20. Addition feels harmless, predictable, linear, but rotations do not behave that way. Turn a book 90 degrees to the right, then flip it forward 90 degrees. Now reverse the order. Flip it forward first, then turn it right. You do not end up in the same orientation. The final result depends on the order of operations. Rotations do not commute. That sounds technical. It isn't. It means that orientation lives in a different kind of mathematical space than position does. Position lives on a flat grid. Move east, then north, it doesn't matter. You end up at the same point. But orientation does not live on a flat grid. It lives on a curved structure, a sphere of possible directions, a landscape where order matters. The gyroscope behaves strangely because it lives in this curved rotational world. Its angular momentum is not just amount of spin. It is a direction in a curved space of orientations. When you apply a torque, you are not adding a simple arrow. You are rotating an already existing direction. That sideways precession you observed, it's the geometric consequence of combining rotations in a curved space. Now pause. You assume velocity behaves like position, that speeds add like distances, but special relativity quietly tells you something unsettling. Velocities do not add linearly. If you move at half the speed of light, and I move past you at half the speed of light, we do not measure each other at the speed of light. The result is less, always less. The rule for combining velocities is not simple addition. It has a denominator, a correction, a distortion, which means velocity does not live on a flat numerical line. It lives in a curved structure. And in curved structures, composition behaves like rotation. Order matters. Approach matters. Limits appear naturally. The reason you cannot exceed light speed is not that something blocks you at the last second. It is that the geometry of velocity itself bends as you approach that boundary, just like the gyroscope's motion bends sideways when you try to redirect it. You thought rotation was a special case. It isn't. Rotation is the clue. It is the first hint that motion is not arithmetic. Motion is geometry. You still imagine a number line, 0 at the center, light speed far off to the right, and you imagine yourself walking toward it, step by step, faster and faster. There is no wall on a number line, no cliff, so why can't you cross it? Because velocity is not on a number line. It only looks that way at low speeds, the way the earth looks flat when you stand in a field. At small velocities, addition behaves normally. 10 plus 10 equals 20. The corrections are tiny, invisible, but as you approach light speed, something begins to curve. Relativity gives you a formula for adding velocities. It does not simply sum them. It divides by a factor that grows with speed. The closer you get to light speed, the more the geometry resists further change, not with friction, not with force fields, with structure. Think again about rotations. Imagine trying to point an arrow exactly toward the north pole of a sphere. As you get closer, each step rotates you less and less in terms of latitude. The geometry squeezes your progress. No matter how many small rotations you add, you never overshoot the pole. The structure of the sphere prevents it. Velocity space behaves in a similar way. It is not flat. It is curved in such a way that light speed forms a boundary, not a physical wall, but a geometric edge. When you accelerate, you are not sliding along a straight track. You are rotating your state through space-time. At low speeds, that rotation looks like simple acceleration. At high speeds, it begins to distort time and length. Clocks slow, distances contract, not as side effects, as consequences of the geometry. To reach light speed would require rotating your state all the way to a limit position, a kind of edge orientation in space-time. But here is the problem. Massive objects cannot occupy that orientation. Just as a rigid object cannot be smoothly rotated into every possible configuration without encountering constraints, matter cannot be rotated into the light-like direction. The energy required does not just increase, it diverges, not because the universe is being dramatic, because you are trying to push a geometric state to an unreachable boundary. You thought speed was additive. It isn't. You thought acceleration meant stacking velocity. It doesn't. It means rotating deeper into a curved spacetime structure. And in that structure, light speed is not a milestone you haven't reached yet. It is a direction you cannot align with. You think light is special because it moves extremely quickly. 300,000 kilometers per second, a large number, impressive, but still a number, and numbers can, in principle, be exceeded. This is the mistake. Light is not special because of how fast it goes. Light is special because of what it is allowed to be. In spacetime, every object traces a path, a world line. If you are standing still, your world line points mostly through time. If you move, it tilts slightly toward space. The faster you move, the more it tilts. At everyday speeds, the tilt is barely noticeable. At relativistic speeds, it becomes dramatic. Time slows, length contracts. Your orientation through spacetime is changing. Acceleration is not just gaining speed, it is rotating your world line, and here is the critical point. Light does not have a tilted world line. Light exists exactly on the boundary between space and time. Its path is neither mostly through time nor through space. It lies along a limit direction, what physicists call a light-like trajectory. That boundary is not just another angle you haven't reached yet. It is the edge of the geometric structure itself. To become light-like, a massive object would have to rotate its world line completely onto that boundary. But massive objects always retain a component pointing through time. They cannot eliminate it. If they did, their proper time, the time they experience, would stop. And an object that experiences no time cannot evolve, cannot persist, cannot exist in the way matter does. So, when you imagine accelerating a spaceship to light speed, you imagine tilting its motion further and further forward. But what you are really imagining is rotating its space-time orientation into a configuration that is not accessible to mass. Light is not very fast matter. Light occupies a fundamentally different geometric category. It does not sit further down the same road. It sits on the boundary of the road itself, and boundaries in geometry are not crossed by effort. They are defined by structure. You cannot exceed light speed for the same reason you cannot rotate north of the North Pole. Not because you lack strength, because there is no direction beyond it. Science fiction loves to imagine bending spacetime, warp drives, wormholes, folding the universe like paper. The idea is seductive. If you cannot go faster than light here, why not take a shortcut there? But the gyroscope already warned you. Motion is not a simple addition of vectors. Not here, not in curved space, not in a folded universe. When you spin a gyroscope, it does not collapse or vanish when twisted. It precesses, sideways, predictably. Geometry governs the response. Warping spacetime is no different. You are not pushing objects through a void. You are twisting the fabric that defines motion itself. Even if you compress distances ahead of you and expand them behind, every particle, every atom, every photon still obeys the local geometry. Locally, nothing exceeds light speed. The shortcuts do not break the geometric rules, they merely redistribute distances. And the redistribution has limits. Imagine bending a sheet of paper infinitely. Stretch, fold, twist. Eventually, the material resists tears or ceases to exist as a continuous surface. Spacetime is not immune. It is not a playground for arbitrary shortcuts. It is a structured continuum with constraints encoded in its geometry. Even the most exotic warp or wormhole obeys relativistic addition of velocities in its local patches. The speed limit is not a signpost. It is a law of combination, a rule of orientation. Think back to the gyroscope. Force does not translate into motion the way you expect. It rotates, diverts, rearranges. Now imagine accelerating through a warp bubble. You are attempting to stack velocity in a space that already curves and twists under your influence. The result is never a simple linear addition. You cannot linearly pile on speed until the light barrier collapses. Local rules always apply. Curved spacetime allows clever rerouting, but it does not permit violation of geometric structure. Every shortcut obeys the same orthogonal precessions, the same hidden rotations, the same relational constraints you saw in a spinning wheel. The illusion of FTL travel is seductive because it ignores the subtlety of motion. You picture adding more speed, You picture bending a straight line into a loop, but reality is not additive. It is rotational, relational, constrained. Warp drives do not escape the law. They merely illustrate it in a more elaborate stage. The geometry resists, reshapes, and preserves the cosmic limit. Your intuition fails again. What you hoped would bypass the rules instead highlights them. Faster than light travel is impossible, not for lack of imagination, not for lack of energy, but because motion itself, the fundamental structure of spacetime, will not allow it. You have been imagining limits as obstacles, barriers to overcome, challenges for better engines, problems for clever engineers. But the universe is not hostile, it is structured. The gyroscope, processing sideways, whispers a quiet truth. Motion is not a commodity you can spend. It is a geometry you inhabit. Faster than light travel is impossible, not because we lack power, not because we lack technology. It is impossible because reality itself enforces orientation. It enforces relationships between space, time, and motion. Every push, every acceleration, every attempt to add speed is a dialogue with the underlying structure of spacetime. And spacetime does not negotiate. When you ignore geometry, when you imagine motion as linear and additive, you expose yourself to illusion. You picture shortcuts, leaps, and jumps that simply do not exist. Consider the gyroscope once more. You tilt it, twist it, apply force. It moves sideways. Every reaction is constrained by angular momentum. No cleverness changes the rule. Now magnify that lesson to the cosmos. Velocity is like angular momentum writ large. Relativity tells you the same story. The faster you go, the more space-time itself resists. Not with friction, not with obstacles, with structure, with inevitability. Light speed is not a challenge to overcome. It is a limit embedded in the geometry of reality. It is the edge direction in the landscape of motion. Attempting to cross it is not failure. It is a category error. You cannot rotate past the North Pole. You cannot push through the light-like boundary, and yet in that impossibility lies awe. The universe is not a playground for linear thinking. It is a tapestry of relationships, of rotations, of constraints woven into the fabric of existence. Every particle, every photon, every spinning wheel follows these quiet geometric rules. What feels like limitation is actually revelation. The edge of light speed is not a wall to hit, but a horizon to understand. The impossibility of faster than light travel is not pessimism. It is the discovery of reality's internal architecture. And now, standing back, you see it clearly. Every intuition you relied on, linear motion, additive speed, simple stacking of forces, is incomplete. You live in a world where geometry is not optional, where motion is not just moving, where limits are encoded in the shape of possibility itself. The spinning gyroscope was never just a toy. It was a teacher, a window, a warning. The universe does not bend to desire. It bends around its own rules. And those rules, precise and unforgiving, define what is possible, what is impossible, and why faster than light travel will always remain beyond reach. Silence follows, not disappointment, not frustration. Only the quiet awe of understanding that reality is stranger, subtler, and more exacting than any of our intuitions dared to imagine.